Almost there, you guys. Question 36. Find the x. Oh, you know what? Let's not worry about this one in rational functions. On the test, it's only looking for the x and y intercepts of polynomials. So all you have to remember is that the x-intercept, to find the x-intercept, you find the zeros. You find zeros, solutions, all the above. For the y-intercept, all you have to do is make x 0, right? X-intercepts the y is 0, y-intercepts the x is 0. But we can go over one before the test later if you want. Oh, that means we're really almost done. So question 37. Graph the function showing all of the asymptotes. So here, you find the vertical asymptote by making the denominator 0, or you're trying to figure out what value for x. Nope, don't do anything. We're trying to figure out what value for x would make the denominator 0, because that's where it's never going to exist, and that's -3 for this first one. So -3, this is going to be the vertical asymptote for this function. And then the horizontal asymptote, there are 3 rules that you need to know for the horizontal asymptote. The first rule is if the degree of the numerator is equal to the degree of the denominator, like we have here. If that's the case, then you're going to have a horizontal asymptote of 0. But if you have the degree of the numerator is greater than the degree of the denominator, you're going to have a slant asymptote, which means the asymptote is actually going to be a separate function that you can figure out by actually doing the long division or the synthetic division. And then what if the degree of the numerator is less than the degree of the denominator? Oh, you guys, I just made a mistake. I just realized it. At the top, it's if the degree of the numerator is equal to the degree of the denominator, that means you're going to take the fraction of the numerator over the denominator. So of the leading coefficients. So here the leading coefficient is 1. Here the leading coefficient is also 1. So on this top one, if they are equal, you're going to take that fraction of 1 over 1. If the degree of the numerator is less than the degree of the denominator, then it's going to be 0. Sorry, guys. It's late and I'm tired, just like you are. So I get the struggle. But in this case, if they're the same, that means it's going to be 1. But then also, you guys, you have your calculadora. Like, please just graph it. If you need to do that, that's perfectly acceptable. Please always graph it if you need to do it using your graphing calculator. So here, it's going to be 1. Positive 1 is going to be the horizontal asymptote. And it's positive. It should look something, because it's positive, it should look something like this. Okay. All right, the next one, you just have to factor the denominator to figure out the zeros or the vertical asymptotes. So 2 numbers that add up to be -1 and multiplied together to be -12 is going to be -4 and +3. So if I factor the denominator, you're going to get x minus 4 times x plus 3, which means that my horizontal asymptotes are going to be the opposite of that, at +4 and -3. Okay, and my, so those are my vertical asymptotes. My horizontal asymptotes are going to be, since they're both the same degree, 2 over 1. So here, cool. So I believe this, oh, I'm going to get it backwards, aren't I? I want to say this will make this graph, but since I'm not going to actually graph it, which I want you to, it could be the opposite direction, in which case it would be this and this and this. Actually, it might be that one because it's positive. Either way, you guys have got it, and we can also go over this before the test too. One more question, and then we're all going to bed. Let's see, 32, 36, 37, and 43. Answer the following questions. Okay, there is a question about this. So here's, I wish I had my highlighter here, but here's what we are saying. Here's how you read this. As x, and then this is approaches. As x approaches 2, and then this means from the positive side, or you could say from the right-hand side. I feel like both are commonly used. So as x approaches positive 2 from the right-hand side, it's like this. What's happening to the function? How high is it getting? What is it doing? It is going to positive infinity. But check it out, right below it, it says as x is approaching 2 from the left-hand side or from the negative side, it's doing the opposite, right? It's going towards negative infinity. Even though it's the same asymptote, if you approach it from different sides, it's doing different things, right? As x approaches positive infinity, so now we're over here. Okay, as x approaches positive infinity, what's happening? Well, that's always going to be, it looks like it's going to be 0 for that first one. Okay, now let's do this all again for the second one. As x approaches positive 2 from the right-hand side, we're looking at this. Looks like it's going to positive infinity. As x approaches 2 from the left-hand side, it's right here. It's going to negative infinity. And as x approaches infinity, positively, it's going this way. It looks like it's approaching. Where's my asymptote here? Positive 2. Cool. All right, so we will have time to answer questions tomorrow. I'm putting web work off until the weekend if you want to get that done, but I will also need those notes so I can mark those off. I look forward to seeing you. Get some sleep, and I will talk to you soon.